Hello, myself Dr. S.C. Vagas from Rajarshi Shaw College of Engineering, Tathodi, Pune. Subject name VLSI Design and Technology. In this subject, VLSI means very large scale integration. In VLSI Design and Technology, VHDL is a very important language. VHDL means very high speed hardware description language for integrated circuit. Here, explain number 3 VHDL code for RAM memory. RAM is random access memory. For this RAM memory, data input, address, clock, write enable, out enable input, and data out. This RAM memory 16 byte storage capacity. Data in is 8-bit input, address 4-bit input on address line, clock 1-bit input, write enable input is logic 1, then out enable input is logic 0, then you write your data in this memory. When out enable input is logic 1, write enable input is logic 0, positive clock pulse is present, then read data from this 16 byte RAM memory. Okay, here VHDL program, VHDL code for this random access memory. The first line, library IEEE, use IEEE dot standard logic 1164 dot all. Package name you mention here. Another package name use IEEE dot numeric standard dot all. Entity name of entity is port, clock, comma write enable, comma out enable, colon in standard logic. 1-bit input on this clock, write enable, out enable. Data in mode, standard logic vector 7 down to 0. Address ADDR in standard logic vector 3 down to 0. Data out standard logic vector 7 down to 0. And end name of entity. Then architecture, name of architecture of entity name is, in architecture type vector array is array 0 to 15 of standard logic vector 7 down to 0. The meaning of this line is vector array is a array. In this array, each locations contain 8-bit data from 0 to 15. The total 16 byte storage capacity. Next line is signal memory. Data type is vector array. After that, next line signal address int unsigned 3 down to 0. Begin process in sensitivity list clock comma write enable. Begin if write enable is 1, then if clock tick event and clock is equal to 1 means positive edge triggered clock is present. Address int unsigned address assigned to the address int, and memory in bracket to integer unsigned address data is assigned to the memory location. That address input is binary data converted into decimal value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Two if statements, end process. Next process clock comma out enable. Begin if out enable is 1, if clock tick event and clock is equal to 1, positive edge trigger clock is present, then unsigned in bracket address assigned to the address int. Data out, you read data in memory location, memory in bracket to integer in bracket unsigned and bracket address assigned to the memory location data assigned to the data out. Again, two if statements, end process, and end architecture name. After that, here simulation result, write enable input is logic 1, out enable input is 0. Here data in 11111 and address is 0010. Then you write this data in this location 0010. Out enable 0 and write enable input is logic 1. Okay. After that, another write enable input is logic 1, 00011 location. Write data for logic 1, 000. Here for logic 1, 000. Write data in this memory. After that, Write enable is 0 and out enable is 1, means you read data from 16 byte RAM memory. Address is 0111 and 0111 location contain 4 logic 1 0 0 0. You read data and that data available on data output. Okay, this is simulation result. Again here write enable 0, out enable is 1, address is change 0 0 0 and this location is 4 logic 0 1 1 on data out port at location for logic 0. Okay, here simulation result of this random access memory. Same program I will run in this here Xilinx software. Okay, wait a minute. Okay, so here in this Xilinx software VHDL programming, RAM memory program already here contained. This RAM memory program, complete RAM memory programs, and after that you check syntax. Syntax is correct. Then here check syntax. Syntax is correct. Then simulation. You click on behavioral check syntax, and then you click on simulate behavioral model. Simulate behavioral model. Here clock input. You applied here force clock. Leading edge is logic 1. Trailing edge is 0. And time delay is 1 nanosecond. Apply. Okay. Write enable input is applied force constant. Write enable input is applied logic 1. And out enable input is applied logic 0. Here. Apply. Okay. And address line. Suppose here address line 0001. Okay. This location you write your data. You run this program here. Okay. Here uh, address is 000, write enable is 1, clock input. Okay, and data input you mention here force constant, and data is 4 logic 0 and suppose 4 logic 1. 8 bit data. Apply. Okay. You run this program. Wait a minute. Okay, so this 000 and 111 data stored in this 0001 location. After that you read data. Okay, uh, write enable input is applied here logic 0. Apply. And out enable input is applied logic 1. Logic 1. And here same address 001 data out. Okay, on this. I will run this program. Okay, you read data and write data. Okay,